All right. So you guys have probably seen the word log before, right? Well, the actual word is logarithmic function. That's what the log stands for, or logarithm. And they are the opposite or the inverse of exponential functions. And they're really, really important because they're the only way we can solve exponential equations. If you have a variable as the exponent, the only way to get him down is to take the log. So that's why we do that. So this would be what a logarithmic function looks like, okay? The little guy that you see that's kind of what we call a subscript that's hanging down there, that's called the base, just like you have a base of an exponential, right? Same thing. Then what's sitting next to the log on the same level is called the argument. So B is the base, X is the argument, okay? And we'll kind of talk a little bit more about the other stuff in a minute, but what you need to know is the argument and the base have to be positive, and they're always positive, okay? And our base does not equal 1, okay? And it's going to be equivalent or equal to this exponential equation, all right? So let's start with, how do we turn logs into exponential equations? So hopefully, I know you guys have learned this, but you may not remember it because it was many, many moons ago, but you'll, okay, get in your little groove here. So here's what we want to do. We want to put the log on the left, LL, log left. You've already got that? Log left. This only works. Okay. So if I put the log on the left, okay, I'm just going to write it over, and I have it equaling y, because we know f of x equals y, then what I always do is start with the base. Okay, I'm starting with the base. Here's my base. I'll write it over. Then I'm going to go counterclockwise in a little circle. I'm going to jump over here to the other side to the y. That's going to be my exponent. And then I come over the top, equals x. That's my exponential equation. That's how I rearrange it. Okay. So base to the y equals x. We just hop around just like that, okay? Now, if I want to go back from exponential to log, okay, let's say that I have this guy, all right? Your exponential is going to be on the left. You want all the stuff on the left. I'm going to write the word log. The base of the exponential is going to be the base of the log. We're going to leave that there, okay? Then I'm going to do the same process. I go over here to x. That's my argument. Equals y. And there's my log, okay? So always start with the base, hop over to the right side, and then equals whatever's left, okay? So it's kind of just this movement over and over and over again. So in my math lab, 4.2 is actually very long, okay? But you're going to have to get, it won't, let me rephrase that. There's a lot of questions on it, but it won't take you too long because they're just little easy, let's rearrange kind of situations, okay? All right, so let's look at this one here. If this tells us to write the equation in equivalent exponential form, that means we want to write it as an exponent. First thing I notice is my log is not on the left. So I'm going to rewrite it. And I'm going to put him on the left. I just rewrote it so that, oh, and you know what? There's a mistake. But I wonder if I fixed it on yours. Does yours say 625 or 25? Scribble through the 6. I forgot that that was a mistake. It is just 25. Good. Okay. All right, so I wrote it so that log is on the left. Okay, now I'm going to take my base, which is 5, go to the other side, exponent of 2, come up over the top, equals 25. And that makes sense. We know that's right because 5 squared equals 25, right? Okay, is everybody okay with that? Kind of remembering how we do that? We're just writing it in exponential form, that's all. Okay, so your first step is just taking that base, raise it to the other side and come over the top. Okay. All right, let's look at this guy. He's already in log on the left form. I'm going to start with my base, which is y, raise it to the 2, come over the top, equals 16. Say that again. No, you don't want log because you're changing it to exponential. An exponential doesn't have log, right? You only want, because you want to get rid of the log and you're going just to the exponent form. Good question. Okay. All right. Now, this is where they want us to stop, but let's just kind of take it a step further so we can just kind of see what's coming next. What's coming next would be they would want you to solve for y. What do you think y would be in this case? You guys are so smart. So it could be 4. It could also be -4, right? But it's going to be 4 because we want our bases to be positive. So yeah, eventually we will go take it a step further and find that y is 4. But right now we're just writing these. Okay, so you get the hang of putting it into exponential, get rid of the log, put it into exponential. Okay, let's go the other way. Now we're going to put it in log form. Okay, so here my exponential's on the left. So I'm going to write the word log, and then I'm going to put his base down here, which is the base of the exponential, which is 6. Okay. Now I'm going to cross to the other side. That's going to be my argument. And then it's going to be equals 4. And that's my answer. Okay.
But do you have to space it out like that? Or can you just like,
What do you do?
I just like bring it all together.
Shove it all together like,
Yeah. Or would I
sure.
be too confused?
You can shove it all together, so I'll take it. Okay. All right. So, okay, part B. So we're going back. We're going to do an exponential, but is our exponential on the left in this case? Is our exponent on the left is what I should say. No. So let's rewrite him. So our exponent is on the left. Okay. There we go. We rewrote him. Now we're ready to start. Our base is going to be 5, right? That's our base that we always start with. Okay, then we're going to go to the other side. Now that's a crazy argument, right? It's kind of weird. You can put it in parentheses if you want to, if it bothers you because you're squishing it all together, or you can leave it, okay? And then you come over the top, and what's that equal? -4. And there's your answer. You don't have to have the parentheses. That's just up to you if you feel like it's too junky. All right, now we're going to get into a situation that's super important. You're going to get a lot of radicals with logs and exponentials. You don't want a radical. You want to change every radical you see, every root that you see, to an exponent. So you guys remember how to do that? What would the exponent on 8 be if he's a cubed root? He's going to be a 1/3. Let's see if we remember that.
Oh, yeah.
That's way back. That's an intermediate thing from like 5 million years ago. Okay. What if we have, okay, the square root of 2? Okay, let's just practice a few. The square root of 2 would be to the 1/2. Good. It's always going to be 1 over the index of the root, right? Okay, good. So that's what we're looking at. Okay, so what we really have in C is this situation. Now we're ready to change it to a log. So we're going to have log of 8. That's our base. Arguments 2 equals 1/3. And there we go. Okay, pretty good. We got that flipping back and forth pretty good. Okay, if you have your calculator, get it out. If you don't, just get out your phone. You know, that'll work too. But I just want you to kind of be able to play with some of these a little bit on your, and figure this where your log stuff is. Okay, so there's 2 types of logs. there's what we call the common log, which is just log x. If you look on your calculator, you see him as just log. See that? Notice that he doesn't have a base. It's kind of like when you see the square root of something, how do you know what his index is? It's squared. It's just kind of understood. If you don't see an index, you know it's a square root. Well, if you don't see a base on a log, it's a 10. It's understood that it's 10. So the only log you have on your calculator, unless you have the fancy big boy, and I'll show you him in a minute, is log base 10. And that's the one that says log. Okay, that's log base 10. So it's understood this has a base of 10. Okay, all right. The other log that you have on here is ln x. And if you look, he usually sits right by regular log, ln. He's also a log. He's called the natural log. He's really a log with base e. Remember E, Euler's number we talked about yesterday? So that's him. So these are going to be 2 test questions worth 5 points each to boost your grade. So don't miss them and ruin your grade. Where it's simply going to ask you, if you see the common log, and it'll show you log x, what's the understood base? And you write 10. It'll say, what if you see the natural log, ln x? What's the understood base? You're going to write e. Okay, so that's just meant to help you, not to hurt your grade.
So that's gonna be the test.
That'll be the
Just
test.
like exactly like that, we have to pretend.
Exactly. Okay, so let's look at some other log rules. There's a couple other log rules. Then we're going to jump right in and start solving logs, and then we're going to find out how to put them in our calculator. Okay, 2 other log rules. If your base and your argument are exactly the same, the whole thing equals 1. So for example, my base and my argument are the same, whole thing equals 1. You don't even have to think about it. Now I'm going to take that a step further. The reason that it's 1 is because it's going to be whatever exponent is on that other guy over there. Okay, so if you were to see, for example, log of, I don't know, 3 to the 4th, let's say you see this situation. Okay, my base is the same as the base of the argument. These are going to cancel, and your answer is going to be 4. Okay, so if your base and your argument are the same, and there's no exponent, or the exponent's 1, it's just 1. If you see something else sitting up there, that's what the answer is. Okay. All right, next thing, if the argument is 1, no matter what your base is, it could be anything complicated you can think of. If your argument is 1, your answer to the whole thing is 0. Yeah, good. Because 1 to anything is still 1. Yeah, good question though. Okay. So these are super important. They're meant to make your life a little faster. So on my math out lab, you're going to encounter a lot of those problems that you can just go through super quick. Okay. All right, so let's try to find the exact value of these without using the calculator. We don't even know how to do that yet because you only have log base 10. And let's see what we can come up with. Okay. All right. So first of all, let's see. I see log. I don't see any tricks that I can really use here. So I'm going to set this equal to y, and I'm going to put it into exponential form. Okay. So I'm going to start with my base, which is 4, raise it to the y, come over the top, equals 64. So I put it into exponential form. Now, using what we know, and this would be the time you could get your calculator out, what do we think y equals? 4 to the what is going to give us 64? Good, to the 3. And if you're not sure about that, just put it in your calculator. 4 to the 2nd is 16. 4 to the 3rd is 64, right? You can play around in there. Okay, let's try this next guy. You are going to encounter a lot of fractions as your argument. So we need to make sure we can handle fractions. All right, well, first of all, I don't see any little neat tricks I can use. So I'm going to set it equal to y and put it in exponential form. So I'm going to take 5 to the y equals 1 over 25. If you see a fraction like this, perfect. If you see a fraction like this, your exponent is going to be negative. That's your clue that your exponent's negative, because we know 5 to the positive 2 is 25. But how do you get the 25 across the fraction bar into the denominator? You're going to make it negative. So in this case, your y is going to be -2. Let's look at that for a minute. Okay, so if this is going to be -2, it's the same as taking your 5 below the fraction bar. It changed your 2 to a positive, and then that gave you 1 over 25. So if you see a fraction, your exponent is negative every time. All right, is everybody okay with that? Remember that little exponent rule? Okay, let's try this guy. All right, so I don't see any neat tricks, so let's go ahead. We're gonna have a base of 14 raised to the y equals 1 over the square root of 14. Okay, so let's think about this. I have a fraction, so my exponent's going to be what? Negative. Now we just have to think about what kind of negative is it going to be? Well, what did we say about roots? What should we be doing with the root? Changing it to a fraction, right? So I could rewrite this as 1 over 14 to the 1/2, right? And then my y is going to be -1/2. That's going to be what puts it into the denominator. Okay. Is everybody okay with that? You know it's going to be negative. Change your radical to that fraction. Okay. All right, because this is really 14 to the 1/2, right? Okay, so I want to make this look like this. So if my 14 was raised to the -1/2, if that's what my y was, that would mean I would put it in the bottom to make it positive. And that's what's going to equal what I wanted to all along. Okay. Kind of a convoluted way to get there. This is more of a My Math Lab than a test question. Okay. So if that kind of bothers you a little bit, it's just a homework situation. I'm sorry. Okay, let's try this guy. All right, I see something fishy going on because I see a relationship between the base and the argument, but I'm not sure what it is. So I'm going to go ahead and put it in exponential form. My base is 4. I'm going to raise it to the y, and it's going to equal 2. Okay, what do we think my y could be if I want the 4 to be raised to something to give me 2? Well, I don't want a negative because there's no fraction. I'm going to raise it to a fraction. What kind of fraction am I going to raise it to? 1/2, because remember this little relationship? Square root of 4 is 2. How do I write square root of 4 as a fraction? 4 to the 1/2. So my y is going to be 1/2. So these are tricky little things, but hopefully they won't give you too much trouble on your My Math Lab. Okay, now this guy, I don't even have to do anything. This is one of the rules. If you look back up here at the rules, what rule is this if my argument is 1? This is 0. And if you want to just look at that as to why the answer is 0, let's think about this. If I set this equal to y, here's my base. No, you can't see that. Okay. And then I raise it to the y, and it equals 1. The only exponent that's ever going to let your base equal 1 is a 0, because we know anything raised to the 0 is 1. So that's why we end up with that. Okay. All right. I know there's like 5 million, but they're going to go faster. Okay. We just want to make sure that we're okay with all these. And then we're going to talk about our calculator a little more. Holy moly. Okay. All right, here we go. I see a log and I see an argument. I don't see a base. It's 10. If you don't see a base, there's a super secret base there of 10. And then what's the answer to the whole thing? Why is the answer 1? Thank you. Maricela yelled because it's a rule, but yes, thank you. Sammy said the base and the argument are the same, so then it equals 1. Good. Okay. Okay. So G, I don't see a base. What's the super secret base? Now, how do we know the super secret base isn't E? How do we know it's 10? Because it's not ln. If it's ln, the super secret base is E. If it's log, the super secret base is 10. Good. So the answer to this one for G is 5. Good. Because the base and the argument cancel, but there was a little 5 sitting up there. Okay, does that make sense? All right, let's look at the next guy. Okay, we know our answer is going to be negative. How do I know? Because I got a fraction. Okay, my super secret base is 10. And I know there's something fishy going on, but I can't really use a rule yet. I need to kind of figure this out. So I'm going to set it equal to y, and I'm going to do the exponential, see if I can figure it out. It's negative because it's a fraction. So I'm going to take the base, which is 10, raise it to the y, and that's going to equal 1 over 10. What kind of exponent would you have to have? What exponent to take that 10 and put it in the bottom? A -1. That's going to move it across the fraction bar to the bottom. Good, you guys are getting the hang of it. All right, the next two only involve ln. ln never shows its base because we know his super secret base is E every time. Okay, so if the base is E and the argument's E, what's my answer for I? 1. Good. All right, what about J? 2. Again, the base and the argument are the same, but this time there's a little exponent up there. So we just take that exponent that you see. Okay, now we're getting a little crazy here. Okay, so here's the craziness. We have a base of 9 and an exponent, which also happens to be a log. Okay, at the core of it, the rule is if you have the same bases, that means for a log and for an exponent, they cancel and leave only the argument. Okay? If your log and your exponent have the same bases, then they go away and it leaves only the argument. Okay, so let's look in this case. I have a base of 9 for my exponent. What is the base of this log? 9. So this whole thing's going to go away. And what is the argument? What does it leave? 3x is what's left. You can have a letter in there. In fact, in section 4.4, you're going to have a lot of letters left in there. Okay, let's look at the next one. I have a base of 10 and I have a log. I don't see a base there. What's his super secret base? 10. Okay, bases are the same. So what happens to all this stuff? Cancels. And what am I left with? Y. There you go. Okay, logs are never as bad as you think they are. Okay. All right, awesome. So let's talk about your calculators. Okay. Okay, let's talk about your calculators. So let me get out my big boy. All right, raise your hand in here if you have one of these gigantic guys. So a few people. Okay. Now, that doesn't mean just because you have one of these that you're also going to have this function, because only certain ones have this function. So let's just see if you do. Okay, and then we're going to talk about the smaller guys, which you can also use your phone for. Okay, for the bigger ones, here's what I want you to try. All right, this only is going to work. Let me find it. Alpha window 5. Okay, let me see. Okay. Do you have any of these green buttons up here above your little, see how you have like Y equals window, zoom, trace, and then you have the blue buttons. Do you have anything else? Do you have green buttons? Do you have anything else up there? Good. Okay, if you have those, then you do have this particular function. So what you're going to do is hit alpha window. That's what you're going to use. I'm going to write it right here, alpha window. And then you should have log base. Can you see that? There's kind of a glare. Log base. And you hit log base. And then it sets it up like this, where you can put in any base and any argument you want. Okay, so alpha window, log base. Okay, not all of them have it. If you don't have it, then you'll just have to do what I'm going to show you how to do on the other little one. Okay. That's okay, as long as you have two little areas to fill in. Okay, let me see yours. Bring it up here. Okay, Shalendra, do you have, oh, you might have something different. Do you have something different?
I just have the exact one.
Oh, okay, okay. Okay, let me see. Makes me think you have it. I feel like you have it, but I don't know how to do it.
It looks like I have.
It looks like you have it.
All capital after the line.
Yeah, and I don't know how to change your base. I don't know how to make that work. You think you're gonna probably have to do. Okay, you got it working? Okay. All right. So if you have this guy, it's super easy. Let's try the log. Let's see, log base 2 of 16. Okay. So if you have this fancy one like this, then you're just going to do alpha window down to log base like this. And then 2 is your base and 16 is your argument. And you should end up with 4. If you don't have alpha window that lets you do that, then your calculator just may not be able to do that. I'm going to show you another way to do it that everybody can do. Okay. All right. Let's look at how everybody can do it. Let's look at the little guy here. Okay. Everybody has a log button, correct? Somewhere, even on your phone. Well, here's the thing. We can use what we call the change of base rule. This means that we can turn your log base 10 into anything we want. Okay. So if I want to use log base 2 of 16, you're going to take the common log of 16, which is the argument, divided by the common log of 2. So let's try that. Okay. So if I want to find this, I'm going to take, now I have to put in 16 first and then hit log in my calculator. I can't hit log 16. I have to put 16 then log, divided by 2 then log, and then I hit enter and you should get 4. Okay. See what I did there? I just used my common log. I took the log of the argument over the log of the base. Who needs help doing that? Let me know and I'll come to you. Everybody get it? Did you get a 4? Okay. Let's try this one over here. Okay. All right, and that works this, now let me do it on this one that doesn't have the fancy change of base thing. Okay, so, okay, so here's how you would do it. You ready? So we're gonna do log of 16 divided by log of 2. And there's your 4. Okay, so log of the argument divided by log of the base. Okay, let's try this one over here. Okay, so you're going to take log of the argument divided by log of the base. Are you good, Cindy? You need help? Oh, you did it? What'd you get? Perfect. You're going to get 3. So here we go. We're going to take 27 log divided by 3 log, enter, we get 3. So you can do it on your calculator, whether you have that fancy little change of base situation or not. You can always do it on your calculator. Is everybody okay with how we did that? Okay. All right. Let's look at a couple of equations. We can also solve equations using exponential form. All right. Here we have an actual equation. We don't have the option of putting equals y anymore. We have a real equation. Okay, so we're going to put it in exponential form and we're going to solve for x. So we're going to take our base, raise it to the 4th, equals the argument, which in this case is x minus 3. And now we're just going to solve for x. So in our calculator, we're going to do 3 to the 4th. Remember how to do that? We would do 3. And then we're going to use our y to the x, 4 equals, we get 81. And then we're going to add 3 to both sides. And we end up with x equals 84. Okay, so you're going to have to start solving equations that have log in it. Okay, not bad. Let's try this dude here. Okay, so here we go. We'll start with our base, raise it to a -4. Uh-oh, if our exponent's a negative, what is our answer going to be? A fraction, and that's going to equal x. Okay, well, first thing I want to do is I want to make this a +4. So how do I turn this into 3 to a +4? Where do I have to move that? Under the line. Good. Okay. Nope, nope, just the negative. No, it did look like that. Okay. Then that's going to be 1/81. There we go. Okay. All right. Sound good? It's not bad. It's not bad. Okay. Let's try these guys over here. Okay. Let's use our calculator for some of these because it's going to make our life a lot easier. Okay. Well, first of all, this guy is kind of wacko because he has a log and then his argument is also a log. Well, we just kind of want to do order of operations. So let's do this little part in here first. Let's find out what this is first. Okay, does everybody remember how to do that on their calculator? We're going to take the log of 81 divided by the log of 3. Remember that? And you can do that in your phone too if you want to practice. Let's see. I'm going to do 81 log divided by 3 log and hit enter. Everybody get 4 for that guy? Okay, so that little parenthesis packet is 4. So I'm going to write this problem over now. That's my new argument. Everybody see what we did? Okay, all right. Now we can put this in our calculator and come up with the final answer. Unless you want to set it equal to y and do the exponential, you know, you can do it by hand if you want to, but now you totally know how to do it in the calculator. So I would take log of 4 divided by log of 2, and what do we come up with? 2. And that's our final answer. Okay, So now that you know how to do it in the calculator, you should be able to do it just fine. Okay, let's try this other guy here. Okay, so for this guy here, all right, we should be able to do him in our calculator. Let's just try him. We would have the log of 1/16 divided by the log of 2. Let's see if we can do that. So it might be a little difficult in this little guy here. Let me try it. You guys are more savvy with your little guys than I am. Okay, so 1 divided by 16. Oops, 1.
You can do the 1 and then do this button.
Oh, with the little
Makes it a lot
fraction
easier. Yeah, it
button?
makes it a lot easier.
Thank you. Okay, so 1. Oh, thank you, dear. Nice. Okay, everybody see what we did here? Very cool. You guys probably knew that. Okay, log. Oh, well, hold on. Okay, log. Okay, divided by 2 log. And we should get -4. Okay. All right, let's try it. So this is what you would do. Priscilla, so you're going to do, let's see, log 1 divided by 16, right? Divided by log of 2. Got it? Okay. All right. Okay, let's try this guy. Okay. You, depending on your calculator, may not even need to make this root into a fraction, but I would recommend it because you're going to want your mind every time you see a radical and a log to turn him into a fraction. So, and if you do that, you're going to see we have one of our special little rules that's going to make our life a lot easier. So if I want to take the square root of 7, how do I write that with an exponent? What would his exponent be? And then, does anybody see a little rule that might apply? The base and the base of the exponent are the same. And you get 1/2. Now, if you had wanted to put this in your calculator, if you'd forgotten about the rule, you could have done log of the root of 7 divided by log of 7, and you should still end up with 1/2, even if you have forgotten the rule. Okay, does that sound all right? Good. Okay. All right, let's talk about this argument for just a little bit. So remember, the argument is the thing that's on the same line or level as the log. Okay, we just want to make sure we're really clear about exactly what's in the argument and what's not. So sometimes you're going to see the argument without parentheses. Sometimes you're going to see it with parentheses. It's really your choice. It doesn't mean multiplication. It doesn't really mean anything other than you just feel like it needs to be set apart a little bit. A lot of times I'll use parentheses if I have fractions, just to kind of set it apart, but it's really not necessary. Here's when it is necessary. When you have more than one term in the argument, when it's being added or subtracted, you have to enclose it in parentheses. You have to, okay? For example, let's look at this guy. What's the argument of this example? X plus 1. You knew that. It was enclosed in parentheses. It was really easy to see. Okay, be careful. What's the argument of this guy? It's just X. It's just X. So that's why parentheses can be very important because, and think about it from a translation situation, okay? Here, what has happened is we're shifting the log 1 unit to the left, right? What are we shifting it to here? 1 unit up. They're two very different things. So just kind of be on the lookout for that. All right, also, I want you to treat the argument like you would a radical. Remember how we said you can't go in there and mess with that stuff under the radical? You can't go in there and cancel stuff. You can't go in there and be weird, right? Okay, same thing with our argument. So let's look at this example right here. This is simplified. He's simplified, he's done. You cannot break into the argument here and cancel out these 7s. You're not allowed to do that. Let's look at this one. This one is also completely simplified. You can't cancel out the word ln. It's not a word, it's an entire function. You can't cancel out the x's out of the argument. You're not allowed in there. So there's really less that you can do than you may think there is. So be real careful with that. Does that make sense? Don't go in that argument and start canceling stuff. Leave it alone. Okay, leave them alone. All right. I know it's the longest section ever. Right. There's just a lot of stuff. Oh, good. Okay. All right. So if you remember, speaking of yesterday's section, okay, if we think back to our graphs of exponential functions, you can just look up here for a second. Okay. They increased and they decreased up there in that above the x-axis, right? Up there in quadrants 1 and 2. They had horizontal asymptotes at the x-axis and they had y-intercepts at 1. Well, your logs are the exact opposite. So guess what they're going to look like? Instead of having a y-intercept at 1, they're going to have an x-intercept at 1. Okay. Instead of having a horizontal asymptote at the x-axis, they're going to have a vertical asymptote at the y-axis. And here it shows you right here, both of those little guys there. Okay. All right. Remember that their domain was all real numbers. This guy's going to have a range of all real numbers. Okay. All right. So if your base for your word log is greater than 1, you're going to have an increasing function that looks like this. It just got flipped on its side a little bit. Okay. If your base is a little fraction, you're going to look like this, and he's going to be decreasing. Okay. It's going to go the opposite way. All right. So let's go through and do that little drag and drop exercise that we did yesterday for the exponential. Let's do that for the log today, just to make sure we're comfortable with it. Okay. Buddy, you're going to have them on my math lab, the little drag and drop.
And not the bottom ones on the test, right? Like you have to find them, like multiple points.
No, not on the test. No, just my math. Okay, so let's see. This guy right here, if you look toward the end, the little lowercase f of x, he's the normal. He's the original. Why he's not in front, I don't know. But nothing's been done to him. So my base is 7, which means that I'm looking for something that looks like this. So as you're looking through your pictures, see if you see something that goes on through x equals 1, right? And that is going to be the picture for log base 7 of x. What do we think? We don't have a whole lot of time, so I'll just tell you. It's 52. Okay, so 52, we're making that increase, and look, our x-intercept is 1. If you look at 51, the x-intercept's 2. And then if you look at 49, your x-intercept's like 6 or something. And then the others don't even curve the right way. Okay, so let's go back to the front then, little g of x.
So it doesn't matter like g of x and h of x.
No, they're
You have
just,
to really look at that.
That's just identifying it, that's all.
Okay.
Yeah. Okay, so if I look back at him, I see a -1 in parentheses. It's going to the right one. Good. So if I'm going to scooch over to the right one, I think it's going to be 51. Instead of my x-intercept being 1, I'm scooching over to the right, and my x-intercept is going to be 2. Okay, there we go. All right, let's try this next little guy. Now he's not written really great, okay? So what I would do with him is kind of write him over. I would say negative log base 7 of x plus 1. I don't like it when they add stuff in the front. I like it when they add it in the back. It messes up my hippo thing, okay? All right, so remember, you can do your hippos seem really violent here. Okay, I don't see anything horizontal. I don't see a stretch or shrink, but I do see a reflection that's out in front. So what is that reflecting over? The X, right? That's reflecting over your X axis. So here's my original. And then I'm going to be flipping the other direction. So I'm flipping the other direction. So he's going to end up, I'm really bad at this, that, right? He just flipped the other direction. And then a +1, he's going to be going up 1. And that looks a whole lot like 47. Okay. So I flipped and I went up 1, flipped over X. Okay, let's try this next guy right here. There's just a -1 in the back. So what's the only thing that's going to be done to him? He's going to go down 1. So again, here's my original. And I'm going to go down 1. I think it's a 49. Okay. All right, this capital F of X, just another way to label it, has a negative out in front. And we already said if there's a negative out in front of the whole thing, we're reflecting over the X axis. Okay, so we're really just looking for this. We're flipping right over. We should still have an X intercept of 1. We've just been flipped. So I think that would be 50. Okay. And of course that leaves this one for the very last one, but let's just look and see. He has a negative, but it's on the X. So we are going to reflect over the Y axis. So this is our original. And all we're going to do is flip over to the Y, right? Say that again. Oh, no, because this is your argument. So he's on your argument. You mean like this? Oh, no, because you got to have an argument. And that's this guy. He's the argument. Okay. All right, let's look at this one. This is the most missed problem on your test, is this. So everybody pay attention. Pay attention, pay attention. Huh? I don't remember. So we're going to go with both. Okay. All right. So most missed problems on the test. We're going to go with both just in case. I think it's B, but I'm not positive. So we're going to go with both. Okay. So this wants you to find the domain of the function. The domain of a log is super easy to find, but students just forget how to do it. Here's what you do. Set your argument greater than 0. Solve for X. Use interval notation. You want parentheses only because this is not an equal to. This is a greater than. So what's my argument for this guy? X minus 4. Did it say worry about the base in any way? We do not care about the base. We do not care about the word log. We only want the argument. We're going to set it greater than 0 and we're going to solve for X. All right, well, this one's super easy. We're just adding 4. X is greater than 4. Now, if you need to put that on a number line to figure out your interval notation, you can. Otherwise, greater than 4 is going to be 4 to what? Infinity. And there's your answer. Okay. Let's try this guy. I think this is the one from the test, but I could be wrong. Okay. All right. What am I going to use here? 6 minus X. Do I care about any other part of that? No. Yeah, good. Set it equal to 0 or greater than 0. Greater than 0. Okay. And I'm going to solve. So I'm going to subtract 6. Divide by -1. What happens if I divide by negative? I flipped. This is why this one's a little stinky. So I want to be less than 6. So where am I starting? Negative infinity, and I'm going to 6. And that's what I'm dealing with. Okay.
that one.
Now, we're not quite done, okay? Because we got to keep it on or we'll never get it all in. It's not hard at all. It's super easy. I don't know why everybody misses it. So let's look at 4.3. Okay, let's look at 4.3. 4.3, we're going to apply some properties. Now, I'm not sure if you guys learned this. I want to say surely you did in Algebra 2. No? But they are all over the SAT and the ACT. They're all over it. So this would be great practice for you, especially if you've got one coming up that you're taking. So there are two commands they're going to give you, two directions. One is to expand your log. That means make it as big as possible. The other is to condense your log, make it as small as possible. What the heck are they talking about? Okay. If you have two items multiplied together in your argument, you can expand it out and make them plus. If you have two items divided, you can expand them out and subtract. If you have an exponent to a power, and it's not something you can apply the rule to, you can take the little power, the little exponent, and stick it in the front as a coefficient. Okay, so let's just take a peek, okay, at these first few. The directions for A through E say expand. That means make as many logs as possible. This means you're going to turn it into addition, subtraction, or coefficients in front. That's what expand means, right? You want as many logs as possible. Turn it into addition, subtraction, coefficients. You don't just want one log, okay? Now, this one's kind of a stupid example, except that it's in my math lab, so that's why I did it. All right, I don't know why in this argument they have 5 times 2. I would say, oh, it's 10 and call it a day, right? But I think the point is they're trying to make you expand it. So the point is these are multiplied together. So we're going to add. So we're going to take log base 3 of the first one, and we're going to add it to log base 3 of the second one. Notice my bases stayed the same. Nothing happened to them. Now, the next step would be to see if you could make either one of these into a whole number. Okay, so in your calculator, you would try log of 5 over log of 3, but you get a decimal, so we leave it alone. Log of 2 over log of 3, you get a decimal, you're going to leave it alone. So there's your answer. You only change it, you only actually go through and simplify it if you get a whole number. Other than that, you leave it alone. Okay. All right, let's try this guy real quick. We'll be done. All right. So I see that my argument has division. So I'm going to change these into subtraction. So I'm going to take the natural log of the numerator minus the natural log of the denominator. Now I'm not done because he still has another problem. Okay, I'm supposed to then take, right, there's 2 ways you can see this. You can either say, oh, he's got an exponent, I'm going to move him into the front. Or what's the super secret base of ln? E. And what's going to happen to these? They cancel. What am I going to be left with? 7. Now, do we think that the natural log of 7 over here could be anything other, like a whole number or anything? No. You could try it in your calculator. That's my answer. Simplify as much as possible. Okay, we'll stop there for today. That's a great stopping point.